Hello. It's so great to be here. I love the energy in this room so far. So today I'm going to be covering best practices behind developing the DeFi, the infrastructure behind the DeFi. A little bit about myself. In 2017 is when I first started becoming interested and found out about blockchain technology. That's when I went down lots of rabbit holes and read lots of books around what blockchain is and how it can be applied to business problems. And then in 2021 is when I was able to join Infura engineering team to build out their quality assurance tooling, which enables me to be here today after 3 years of a lot of ups and downs working in this field. So that everyone has some baseline, I just wanted to speak about how blockchains are databases. We can see parallels here in these 4 layers. At the storage layer, we can appreciate how blockchain stores data in blocks that are linked together to form a chain, whereas databases use tables. And then for the consensus, blockchain relies on consensus mechanisms like proof of work or proof of stake to agree and validate the data that gets saved permanently, whereas databases use business rules and administrators to ensure data integrity. At the network layer, blockchain is decentralized, which means that all the nodes have a copy of that blockchain and all the data in there, whereas with databases, there is usually one single point of control, and there's usually like one person that can delete a database. Whereas with blockchain, it's impossible. There's no one single actor that can delete a blockchain. And then at the security level, blockchain relies on cryptography to make sure that the data is tamper-proof and valid, whereas databases rely on access controls and can be edited by people. Whereas with blockchain, once the data is saved, it cannot be edited ever again. Which leads me to security. So much goes into making sure that users are protected and that there's a lot of trust built into DeFi products. This is just a few subset that trusted DeFi tools like crypto wallets like MetaMask, Coinbase, products like Uniswap, Alchemy, QuickNoid, Infura. We use these types of tools to make sure that our infrastructure has been tested for any security risks, any kind of like errors we do. For instance, diligence does things like fuzzing and smart contract auditing, because even the tiniest errors in a smart contract could mean catastrophic financial consequences. And so a lot of these different products here, Immune Bytes, QuantStamp, Blockade, they go into making sure that users are protected. For example, Blockade makes sure that transactions are safe by simulating them first, just to make sure it's not like a scam token or some kind of fraudulent activity. And so products like Infura and Alchemy use things like these things here, like Blockade. When someone who hasn't used DeFi tools wants to, it should feel the same or easier, ideally. Which leads me to factors of scalability. These 3 factors are critical when thinking about how to scale DeFi and the infrastructure that supports the DeFi. So with regards to throughput, how many transactions a blockchain network can process is pretty important. There's things that limit this, like gas limits, network congestion. For instance, if someone's minting like 10,000 NFTs on Polygon, then other people are probably going to experience a different throughput, things like that. And different networks have different gas limits that alters how many transactions can be processed on that. So for instance, Bitcoin produces new blocks every 10 minutes, and Ethereum produces new blocks every 12 seconds. So that kind of throughput has different behaviors depending on what your use case is. With regards to network latency, several things affect this. For instance, the geographic distribution of nodes. So we find, depending on where you are in the world, whether you're in Germany or Singapore, Asia, or North America, you're going to experience different network latency because the further you are from the nodes that interact with the blockchain infrastructure, the slower it might be for your transactions to finish, just because that's where, depending on where the miners are, where the validators are, that's going to affect your performance. And so it's really important, for instance, like my team at Infura, we want to make sure that our nodes can be properly meeting the demand no matter where they are in the world, whether you're in Asia or North America or Latin America. We want to make sure that the transactions on your MetaMask wallet will work smoothly regardless of where you are. And then quality of service. With quality of service, things that we normally plan for are network uptime. We want to make sure it's always available. Our blockchain infrastructure is always 100%, or we try to aim for 5 nines, so that's 99.999% of the time, our blockchain nodes are up and available and running, so that whenever anyone is processing a transaction on their crypto wallet, they don't notice any performance issues. Another thing to consider with quality of service is data consistency and data correctness. One of the tricky parts about blockchain is that it's a peer-to-peer network of all these nodes. So what that means is all of these nodes might not have the same data at the exact same time. And so it's really important for the blockchain infrastructure provider to make sure that their nodes are all in sync and reporting the right, correct, latest data. Which leads me to what monitoring DeFi infrastructure health looks like. But to look at the big picture again, let's consider traditional finance. When someone wants to pay for something with their credit card, they normally, they'll start a transaction. The payment is authenticated. The credit card company, communicates with the bank that's associated with it, and then the merchant, and then the transaction is authorized. There's normally a request and a response, and then finally the merchant is paid, and then you have your receipt of that transaction. Whereas with DeFi, you'll notice it's a similar 6 steps, where a customer starts with a transaction, probably on their crypto wallet, and then the wallet signs it using the customer's private key. That happens in the back end. And then the transaction is broadcast to whatever blockchain network that's on, whether that's Bitcoin, Ethereum, Polygon. And then the validators validate, make sure that at least 51% of the nodes agree on, okay, this is valid, this transaction is cryptographically signed, and this can now be saved. And so then that block is created, and that transaction is complete. And so what is actually behind that DeFi transaction? When you look at your crypto wallet app, behind that interface are these 14 EVM methods. And so these need to be working flawlessly for a crypto wallet to work. And so all of these methods are different API methods that interact with Ethereum technology so that the user can get the right data, process a transaction, and everything can operate smoothly. And the reason why I'm stating these 14 important methods is because, oh, this might be hard to see, but it's because blockchain infrastructure providers, like the team that I work with, we make sure that all of those 14 EVM methods are working perfectly. And so much work goes into making sure that, okay, the blockchain nodes supporting that one endpoint, ETH call, ETH get block number, their CPU is healthy, their memory is healthy. We measure the error rates associated with that. So right there, like, is a screenshot of that's the ideal, that's the ideal thing I want to see when I look at my team's dashboard is a 0% error rate for ETH get balance, because if that goes up, that means when someone opens their crypto wallet and sees the data that they're seeing, the balance of their crypto account, that it's accurate. Whereas when there's errors on that endpoint, then that might not be accurate, which would obviously be a horrible experience for the end user. And so we monitor things like, what's the latest block? So at this given point, that 208.38806, that was the latest block on Ethereum, on that specific network. And so we monitor how many reorgs have happened, if we're serving the correct data or not. And then finally, that bar on the bottom is the uptime. So we want to make sure it's 100%. It's not always 100%. Sometimes there's performance degradation, or sometimes there's outages or incidents. And so, but ideally, we try to make sure that that's always 100% up. And so the end goal for people that are pro-crypto tech is that people won't even know they're using DeFi. That's the vision for a lot of us and what drives our work. We believe that in the future, it's not even going to be a thing. Whether, when you're making a transaction, you won't even have to think about, oh, is this using my cryptocurrency or is this using my regular fiat? That's the end goal, is for it to be so seamless and comfortable that people don't even have to think about it. And then finally, I want to talk about decentralizing. This is a recent trend that's happening where blockchain RPC infrastructure providers are sharing what would otherwise be proprietary tech in the name of innovation and just helping the ecosystem. And so there's teams such as the Decentralized Infrastructure Network, also known as DIN, that they're building things out so that a lot of different RPC providers can serve the same traffic. So what DIN does, for instance, is customers of Infura can use our blockchain network service, and then on the back end, that could be supported either by Infura or by even some of our competitors, like Alchemy or QuickNode and other RPC providers. And that's okay, because we want to make sure that, because we know that this will increase the robustness of that and the scalability and performance of our blockchain node service. And so just to close things off, just want to recap again that building a robust DeFi infrastructure requires security, scaling, monitoring, and decentralizing, all in the name of innovation. And so now I am open to questions.
Thank you, Jacqueline. We do have a few questions from the audience. What do you think is the largest issue now with how dApps are approaching infrastructure setup?
What do I think is the largest issue now with regards to how dApps are
approaching infrastructure setup?
Approaching infrastructure setup, yeah. One thing that comes to mind is sometimes there's some trendy, excuse me, trendy new networks that perhaps has a lot of funding and they seem really cool, and perhaps there's a lot of incentives for people to use that network, but it hasn't been battle tested, and so whenever that happens, sometimes like a new network will pop up, and there'll be events like build on this network. Look, we're having a hackathon. Build dApps. But then once people actually build the dApps, that network isn't actually set up to scale or succeed, or it turns out it's just really poor experience. Like maybe it just, like again, it hasn't been battle tested. That's one issue that I can think of. Yeah, and I guess a lot of that is influenced by social media, like Twitter, and certain celebrities might influence the popularity of some new hip blockchain networks that, again, just haven't really been properly vetted.
Thank you. One more question. Can you explain how funds flow between crypto and fiat when providers offer both types of transactions to their customers, including card usage?
So how do transactions flow when, yeah. So one thing that I've seen is wallets or tools that support both is they just have all of the required information from the customer or the user. So like if the tool that I'm using allows for both fiat and crypto, then it would need to have, of course, my banking information, right, for normal fiat, and then it would need to have my wallet, my crypto wallet, and so that it know like where to deposit and where to draw funds from. And there's probably more security nuances in the back, but that's pretty much like my simple answer for it. It just needs to have like my required information and perhaps my private keys, depending on what kind of wallet it is.
Thank you. One more question. How many outages or on-calls does Infura get?
Yeah, that's a good question. How many outages or incidents does Infura get? We get a lot. And the good news there is that we're really good at stabilizing things when there are issues. Actually, funny story, sort of, funny now. When I was new on this team, there was an incident where I accidentally changed something that was critical to our infrastructure, and I accidentally brought all of Infura's service down. And within hours, there were Twitter posts and articles written, things like, Infura's down, come to Alchemy, like, you can't rely on them. And I was mortified. And I remember going to my boss, like, I have to resign, this is terrible. And he walked me off the ledge. And we recovered from that, and we learned like some really good lessons. But I guess something that I've learned is that there's going to be incidents and outages, and that's okay as long as the team knows how to handle it and stabilize things, and then hopefully learn from that experience so we can be stronger for the next time something happens.
Thank you so much, Jacqueline.